In this lecture, we're going to talk about the volume pressure equation. Before starting this equation, there are some terms that we should know. These terms are isochoric, isobaric, and isothermal. Now, whenever we set volume constant, so that process is called isochoric process. Whenever there is pressure constant, that is called isobaric process. And wherever there is temperature constant, so that one is called isothermal process. So, let's move on to the equation. Just suppose that this is a container in which its bottom, like this part, is made up of conducting material, while its walls, these parts, are made up of non-conducting material. That probably means that if we want to heat it, so we can only heat it by the bottom. Now, just suppose that here in this bottle I have done volume constant. That probably means that this is a pistol, which I have locked this pistol by some type of a screw or locks. I have locked these pistol. Now, when I will provide heat to these particles will start to move. Now, when these particles will start to move, so there will be production of kinetic energy. And this is how we drive our equation. Now here, we all know that Q is equal to del E plus W, in which we know that law of thermodynamics state that Q is also equal to del E plus P pressure and del V is equal to change in volume. Now here we know that in our pistol the volume is constant. That probably means that there isn't any change in the volume. So here the volume will be 0. If we will place the volume as 0, so by multiplying it by the pressure, so pressure will be also 0. So in our final answer, the Q change will be equal to the change in the internal energy. Now this is how when we constant the volume, so our change in enthalpy becomes equal to change in internal energy. I hope that this equation is clear to you all. So let's move on to another equation. Here in this equation, what you have to do, you have to constant the pressure. That probably means that there isn't any change in the movement of the particles. If there is any movement of the particles, so there isn't any change in the pressure. When we're gonna heat up this, so the pistol will move up. There will be change in the volume too, plus there will be change in the kinetic energy too. Now how are we going to drive its formula or the equation? So this will be the equation. Now as we done, Q is equal to del E plus pressure and change in volume. Now we know that del E is equal to E2 minus E1, change in internal energy 2 minus change in internal energy 1, initial and final. And we know that here pressure is constant, so we're going to take pressure common. That probably means if we're going to multiply that, so change in V equal to V2 minus V1. And here is the pressure. Now multiply pressure by V2 minus V1, so it will be PV2 minus PV1. After that, we're gonna sum like this PV2 with E2 and this E1 with PV1. So this will be the equation. Now here one thing to be noted is that we know that here E minus PV is equal to enthalpy. If we talk about E2 minus PV2 and E1 minus P1, so basically that will be equal to change in enthalpy. So if we're gonna constant the pressure, so internal energy will be equal to change in enthalpy. And this is how we derive both of the equations. I hope that these equations are clear to you all, and thank you so much for watching this video.